Hello everyone. In this video, I'm going to explain how to run regression analysis and how to interpret the result of a regression analysis. I better start with the idea of regression equation. Let me jump to slide 3. Now, as you see over here, regression equation is determined by the sum of squared errors. I'm going to explain this pretty soon. So simply put, regression analysis is based on the minimum sum of squared error among so many different options. So let me just move to the related graph. So let's say you have 1, 2, 3, 4, 5, 6, 7 data points. Now, it's not possible to make a line when you connect all data points. It's going to be weird looking curvilinear line. Excuse me. Now, however, we like to have one simple, straightforward line, which is like this. That is simply regression equation and regression line. Now, there's a big difference between these two graphs. This is just idealistic situation graph, and this is the real data point and one best fitting line. Now, as you see, one line can be put among those several data points, end up having this line. Now, this line is predicting y value when we know x value. Let's say if we know x value is 3, we are able to predict the y value, which is about 7. That may not be actually correct, because as you see over here, data points are like this. And when x value is 3, then actual y value is 9. But according to regression equation, we predicted that when x value is 3, corresponding y value is 7. So it's not 100% correct at all. Now, what this means? Now, we simply prefer straightforward line like this for many reasons. So when we do that, as you see over here, there's a actual error in terms of predicted y value and actual value. This data point, actual the y value, corresponding y value is about 3, but based on this regression line, when x is 2, predict the y value is 5.8 or something, okay? So many errors can be possible when we are using regression line or regression equation, but still it brings a lot of benefit to researchers, and we prefer that way. Simplicity is always what we want to have. Now, when you look at this y value, you see the dot line. Those are possible error when we are predicting y value based on a regression equation. So the statistical software, including Excel, calculate that and found minimum sum of error, which is will be actually squared. This is a squared error. When we add all those errors, statistical software choose the line, regression line that has minimum sum of squared error. That's why it is called the least squared error solution. So least squared error solution is the most commonly used approach in regression analysis field. Now, just a sec. Regression analysis is the most powerful tool in statistical testing, and really a powerful tool for predicting dependent variable, which is y value. However, there are several assumptions we need to pay special attention to. These four assumptions are major ones, and if some of these is violated, we need to fix that by taking a different tool, and I'm not going to explain those. One of them is homoscedasticity is assumed, but if it is not homoscedasticity, rather it is heteroscedasticity, then we need to do some additional jobs. But again, I'm not going to cover that. And simply put, regression analysis is based on some major assumptions. Some are very critical, others are not really that much critical. But regardless of that, we should pay attention to those assumptions. I know you guys ran regression using Excel before, but this time I'm going to show you an example and how to interpret the result of regression analysis. Let me open up a data set, and this is a world data set, one of the data set I posted in ASULearn, and I am going to choose life expectancy for male and literacy rate. The possible hypothesis I'm thinking of is if literacy rate is going up, then life expectancy for male will go up too. Using common sense, that simply makes sense, right? So I am copying column G and H and actually pasted it in the different worksheet. So again, this is independent variable, and life expectancy for male will be dependent variable. Now, before running multiple regression, actually multiple regression is not allowed in Excel. Only one independent variable is allowed. However, it generates pretty much same regression analysis result compared to other professional statistical software. So we will pay attention to the result and how to interpret that, okay? So before running regression, we need to verify when we are using Excel that whether or not there's a missing value. I found this cell has no value, which is missing. In this case, we need to delete this pair. So I'm going to delete and choose delete. I will check other missing value. Okay, same thing. I need to delete this pair. Excel is very sensitive to missing value. When there are missing values, Excel will show error message, okay? And also, if independent variables observation number and dependent variables observation numbers are not same, then we should make it equal like this, okay? So now it's ready to be run. The regression analysis. Okay, I am going to choose data menu and click data analysis. Okay. Now we needed to choose regression. Okay. Now y range, y is obviously dependent variable. In this case, life expectancy for male. If you choose a whole column for y range and whole column for x range, you will not. I did that, I tested that, I didn't get the result. Rather, you better for dependent variable range, you better choose values only from A2, okay, until the end of values. Okay, and stop. For dependent variable, which is x range, independent variable, let me go up. Again, choose values only from B2 until the end. Okay. Now you don't need to check anything, and the regression analysis result will appear in new worksheet file as a default. So click OK. Now this is pretty much about what you get. Let me just adjust the width. Okay, the first table shows you important information, which means you need to pay attention to R-square value. And actually, adjusted R-square value is more precise. So I ask you to check adjusted R-square value, which is 0.65. That means, excuse me, this means the dependent variable will be predicted by independent variable for how much? 65%, about 65%. So which means this regression equation has a predicting power of 65%. Okay, so this can be called predicting power. This is pretty high, and observation number is 107. As we remember, there are 107 independent variable and there are 107 dependent variable. So this R square, adjusted R square, is the squared value of R coefficient. Okay. So again, this is a predicting power. Now, the second table is ANOVA. We learned ANOVA. We learned that we are using F statistics. Okay. Now, what does this mean in regression analysis? This means, let me just adjust the column F. Okay. This means that ANOVA explains whether or not your regression equation is acceptable. If ANOVA, excuse me, if ANOVA's p-value, which is here, p-value is higher than 5%. In this case, way lower than 5%, but if ANOVA's F statistic is higher than 5%, you can conclude that your approach in regression analysis is not acceptable. Okay, so which means you needed to choose different independent variable. Now, you will have ANOVA table even when you have 2, 5, 10 independent variable, which is not allowed in Excel, but regardless of independent variable, you will have ANOVA table in regression analysis. Okay, so pay attention to p-value, which means way lower than 5%. So your approach, your regression equation is acceptable. Okay, so you are good to go. Now the last table is about your chosen independent variables power in terms of level of significance. The p-value. Okay, so this is intercept. Just ignore that. You need to pay attention to x variable 1, which is in this case literacy rate. So when you look at p-value related to literacy rate, which is variable 1, it is pretty much lower than 5%, which means the literacy rate has a significant and coefficient is positive, significant and positive impact on life expectancy for male, right? So your hypothesis is supported. If you have more than one independent variable, which will be allowed in many professional statistical software, those additional independent variables will be listed over here, and it also has a p-value for each. So you can interpret one by one. Okay, this one has positive and significant impact on dependent variable, and second independent variable may have a different p-value and different maybe negative coefficient. So depending on p-value and sign of coefficient, you will just need to interpret that. Okay, so um, so in your project, you needed to include uh, these three tables, and then reasonably explain what you found based on this table's value for each hypothesis. Okay. Yeah, this is the regression analysis. Is the most powerful tool for testing hypotheses and predicting y values. And the beauty of regression analysis is, regardless of a number of independent variables, let's say x variable 1, x variable 2, 3, 4, 5, 6, whatever the number is, we are able to look at one independent variable at a time. While we are looking at one independent variable at a time, all the independent variables will be controlled for, which means let's say in this literacy rate, another case household income and different kind of thing. While we are looking at literacy rate effect on life expectancy for male, it will not be affected by any other independent variable because it will be controlled for, which means they are going to be held constant. Okay, so they are simply under control, and you are able to focus on each independent variable related effect on dependent variable one by one. That's why researchers, including me, love regression analysis. Although there are assumptions researchers need to pay special attention to, like multi-collinearity, homoscedasticity, and those kind of things needed to be considered, but we can enjoy the regression analysis approach when it comes to predicting y values, when it comes to predicting the effect of independent variable. Okay, I believe that's pretty much of this lecture in this video. Thank you guys.